Hi, I'm Tim,
And I'm Kevin.
and we're from the Steel City Robotics Alliance with SCRA
In 3D! All right, so today we're going to be talking about our prototyping and then our shooter and our Kitbot improvements.
We really want to take some time and thank all the small team, but powerful team that came out to help out and work on this project. Cole, Colum, Alex, Ben, Logan, Jonathan, Dane, Curtis, Ryan, Liz, and we really want to thank the Girls of Steel 3504 for their facility and letting us use their tools and parts for this activity.
So I'm going to go ahead and talk about some of our Kitbot modifications. So we built a Kitbot this year, starting off right after the kickoff in the game reveal. We started having people build the base of the robot, and then that night we finished building the superstructure so that we could then start modifying the Kitbot. One of the modifications we had was this climber system here. So it uses the Max Planetary gearbox from last year if you built an Everybot. We changed out one stage there to a 5-to-1 so that in the end it is now a 125-1 gearbox reduction instead of the 75-to-1 gearbox reduction from last year. It uses a winch system that pulls down on here, and then to bring it back up it has elastic tubing or a bungee cord to be able to lift yourself back up and have it rise up. There is a bearing point on your superstructure that you just drill out and then use a 1/4-20 bolt to be able to put your superstructure to your climber. And then we also ran into some issues. We originally had the battery on this side of the robot with a shooter. We had to flip the whole superstructure around so that the battery's on the other side, so it's easier for us to actually be able to balance whenever we're lifted off of the ground. The chain that we have set up here is not an exact replica of what will be on the real fields, but it is an approximation that we think is good enough for being able to test this. So a couple other things of note for the climber system. We had to put the Neo into brake mode. So there's two different kinds of hold modes for your motors. It can be either coast, which is going to allow it to spin freely, or brake mode, which runs while your robot isn't enabled, but it shorts some of the phases together and things like that to be able to have the motor more resistive to somebody trying to change the state of the motor. So whenever you're pulling on this, if it's in coast mode, it's able to pull if you're having it pull really hard, but then whenever it's in brake mode, you're not able to actually have it pull out. Is that reasonable?
Yep.
Okay, cool.
The top upper arm structure here is made out of 1/2-inch plywood. The 1/2-inch plywood fits very nicely in between the links. You'll notice that the profile here is a very narrow slot. That profile helps to prevent the chain or the robot from moving laterally onto the chain and helps to lock it in. As much as many people might think that polycarb or other materials might be better, we think that that plywood is a great material for this and is easily replaceable by changing out a bolt and having some long drywall screws into a 2x4. It should hold up if you are properly inspecting it and looking at it in between matches. It's also very easy to get a couple people to make some of these for you, and you could even cut this shape out and do all of this work with just a jigsaw and be okay.
So we also have this motor. It can't be cantilevered is one of the issues that we were having. So we added a second Max Planetary faceplate here that has the output shaft, and then that is being used just as a bearing block to support the other end of the shaft. Whenever you have a cantilevered shaft, it is being extending out and then it can pull up like that. So if you add on a bearing block, it can no longer get pulled up.
The ratchet strap is actually just looped around and still actually has the steel hook up and top. You could change that around, but leveraging the existing sewn portion without having to cut anything is pretty nice and convenient. Down at the bottom here, we simply drilled a hole laterally or cross-drilled through the hex shaft and bolted and put a washer on for the ratchet strap.
Yeah, and we just cut a small hole in the ratchet strap and then used a large washer to be able to secure that to the hex shaft without it pulling out.
The Max planetary gearbox set is mounted directly to 2x1 tubing that then right now in this shot is C-clamped to the Mark AM1 for you gearbox, or sorry, chassis. In real life, you should bolt this down. We just didn't have that much time.
So some other things that we have modified on this particular version of the Kitbot. We have a separate electronics level here. So ordinarily, we would probably see this PDP put on the lower section of the base wood that you have in the instructions for the Kitbot. However, then you're going to have issues with trying to get your screwdriver, if you have one of the older style PDPs, getting a screwdriver in there to actually be able to insert the wires. Even with the newer PDPs, getting your hands and the wires in between your motors is going to be a challenge. So what we did was we just put it on 2x4s to support it up, and then we put a second layer of plywood there so that we have the PDP and the motor controllers on that, so that you don't have to be reaching inside in between your motors to be able to have any repairs done to your electronics.
We used older Talon SRX motor controllers because this chassis is running the sim motors. That's probably okay. However, if you would like to do autonomous, the easiest way to upgrade to do a reliable autonomous and to get a little bit more power is to change those sims out for brushless motors.
Yeah, the brushless motors have integrated encoders in them, so then you get position feedback, speed feedback. They are more expensive, but if you're trying to do autos where you're going a certain distance specifically, then you can have the motors already built in with the encoders and not have to add on any encoders separately.
A lot of you received those motors maybe with first choice or in your kit of parts, and it's a great place to use them this year is your drivetrain. In the coming days, we'll try to test the Climber with just a sim motor and see if that works instead of using a Neo on there. However, we think that the Neo is probably the best for that system.
Yeah, and anyone who built the Everybot last year, I believe, will have most of what you need for doing this Climber already. We also, for the electronics, added a camera on here so that you can actually see where you are on the field, being able to line up your robot to the game objects. Whenever you're far away from your human player station, you're going to want to have some sensors on your robot to be able to have some things of being able to see where your robot is whenever you're not right there, being able to see it directly in front of you.
Something that is really important that we figured out, or Kevin figured out, is that by simply adding this lovely little piece of polycarbonate here that you might already have in your shop from a cutoff from this flap here allows the robot to score into the amp. Now, it needs two different things added into there. A small block of wood off to the side right here to prevent notes from skipping off, and then a small little block here that prevents this from all the way flapping down. We're using gaffer's tape here as hinges simply because we know that for some teams doing this, purchasing becomes a problem, and even getting a hand on something as cheap or as readily accessible as a hinge might be an issue. Gaffer's tape is another one of those things that could work great in this, and would probably survive pretty well. However, you might want to replace it with something more robust, and if you're using it, you should definitely pay attention to pre-inspections during games.
Yeah. So this flap actually starts off up here, and that wood block also allows you to have it resting here so that whenever your robot is starting up, you can just drive forward, stop really quickly, and then the inertia will pop it open, and then you can shoot in your high goal already. We also added in the zip tie here so that it pulls down on the center of the plexiglass here so that it has a funneling kind of effect for being able to get notes from the human player station easier. That did run into some other issues because as you bend this sheet of polycarb, it would bend and then flex into your shooter wheels. So we ended up cutting out a little area to allow for clearance for that wheel so that it can do that. We also had to raise the top section of plexiglass up with washers to be able to have a little bit more of a gap there for the note to be able to go through without any friction on either side and being compressed.
This is some of the upgrades that we've made to the Kitbot in the past couple of days to add capability to them. We think that there's some great upgrades that improve the competitiveness of the robot. They are not the only upgrades that you can make, and you can make a lot more. We continue to encourage you to build your Kitbot and take and explore upgrades of your own. Get out and try to drive it and test it as often, as quickly as you can, because the more driver practice you have and the more testing you have, the better you're going to be in competition.
Yeah, these are just some starting points for you to go off of. None of this is perfect. It was all made in 3 days. I think that if you have some ideas, it is always great to try them. If it works, awesome. And if it doesn't, that's not a problem either. You learn more from doing something and having it not quite work, and then being able to fix that problem and fix the next problem and fix the next problem than if it just works the first time.
We know that in doing robot development, prototyping and those first iterations of prototypes and getting them done really quick is important. We looked through a whole bunch of stuff on Chief Delphi and other places, and we found a few really cool resources, and then we kind of adapted them. 6657 had a really cool intake prototyping system that was this bar and a couple other pieces that we iterated on. And then 5254 had a great system called height blocks, which were 3D printed things. Due to a lack of time, Kevin came up with a really awesome innovation on that, and he can talk about those.
Yeah, so we just took the plywood and then used a router to route out something very similar to their height blocks. However, this version has support for being able to have a 2x1 here or here, and then it also has holes for being able to put a 1x1 in either orientation as well. We also have a 2-inch circle of holes for being able to mount any sim-style motors or sim-style gearboxes. So the Max Planetary system will work here, and then also the Neo Vortexes worked out very well with this as well. It also has a bearing hole cut out in the center there, so you can either have your motor or a bearing, and then they're all at the same height, and then you can clamp them onto your 2x1 and then be able to move them along as you loosen them and then move them to wherever you want, so you can have different spacings between your rollers or being able to have very quickly assembled devices.
So it's really similar to Thrifty Bot's bearing block plates or a couple other companies' bearing block plates. The difference, though, is that this is plywood. It's really cheap, and you can cut this and make it do whatever you want. And you're also not waiting for hours for a 3D printer to do that, or maybe even minutes with a Bamboo. So.
Yeah, so for one of our intakes, we started off prototyping and we used both of the systems of routed parts that we routed out before kickoff, actually. And then you can just take wood screws and then screw things together, get all sorts of interesting geometry to be able to have just like You bolt them together, and then you can measure out the distances between them that are working, and then you can come up with something that you can route out later that then has everything fixed geometry. And it lets you get the hole spacing and also figure out different things really quickly, be able to bolt on something else without having to worry about, waiting for the router to finish your job.
This whole entire intake process was done in probably about 3 hours, from first idea and iteration and test with drills to a plywood version like that. And this was also tested with drills. And then the next iteration had belts and pulleys integrated on that with the motors. So.
For our shooter prototype, we started off with an idea for doing a top and bottom roller shooter. We originally thought that it would be the hex spacer is about the diameter of the inside of a pool noodle. So we tried doing that, put some tape around the hex spacer and then did that. It didn't work all that well. So we looked around the shop and we were trying to find what else do we have. And that was a cardboard shipping tube for McMaster. And we just took the cardboard tube, we routed out some wood plugs, and then had a place for a hex hub in the middle. And then we shoved it in each one of the ends. And then we ended up taking and putting it onto one of our routed out motor blocks. This one we had to modify slightly, which was awesome because it's just made out of wood. And we didn't account for the size of the Neo Vortex. So we just went onto a bandsaw, cut out that shape so that it can fit around the back end of the Spark Flex. And then we have a shooter prototype really quickly done. We just had 2 of them. Well,
of course it's not fitting.
It's not gonna fit right now. But we had 2 of them, one right here, one right there. And then we had the note going between the rollers. So after the cardboard was proven, we were able to shoot across the full field with that. So we tried to say, hey, what can we do instead of a cardboard tube? So we decided run out to Home Depot, buy some PVC pipe. We got PVC pipe, did a very similar thing with the press fit hubs inside, and then tested it. So one of the things with the cardboard tube is it actually has a rougher surface than the PVC pipe. So I think that we were actually getting some slightly better results with the cardboard tube than we were getting with the PVC pipe. We did not do any testing for changing the friction on the pipes because it was working well enough for our purposes, but throughout your season you might want to try different surfaces on your rollers.
We also tried multiple different rollers with a 4-roller configuration. That one didn't work as well, and we went back to a single top and bottom roller configuration. Brief parts of the Ri3D SCRA 3D robot that the group designed and built. The first part is over the bumper intake, and then the second part is the shooter and transfer part. You'll notice that these are very non-traditionally mounted 90 degrees apart from each other. The idea here was to design the robot to help optimize for mechanical, to optimize for autonomous situations. So we wanted to optimize for the auto route where we were going to be able to take and intake, transfer, and then strafe to the right. When looking at this, the transfer from one to the other turned out to be much harder than than the group initially thought of, and so this transfer would have to come down, and then this would transfer across. Turned out to be very impractical. Who would have guessed? That's okay. Now you'll also notice on the rollers here, we have the vortexes, and they're kind of mounted outboard. In a real competition robot, we wouldn't do that. We would have done them with a little bit of different packaging where we would have put the vortex on the inside of the plate and then had the tube coming around that, but still had that center shaft. We wouldn't have been mounting to the outboard runner here. we would have used that hex shaft. And then on this side, we would have had this really removable and with shoulder bolts so that you could get in and do any easy replacement. Interesting set of packaging possibilities that the new Vortex brings out into the FRC market. Pretty cool little motor. So on behalf of the whole entire SCRA in 3D team, we want to thank you for watching the videos. We look forward to going to competitions and seeing what amazing creations that you build in your whole entire build season. And thank you for coming and seeing SCRA
in 3D.